Beryllium hydroxide is insoluble in water, but calcium hydroxide is soluble in water. But why? Let us see the matter in detail. Before this, let us try to know what are lattice energy and hydration energy. Lattice energy. Sodium chloride. Let us consider 1 mole ionic compound sodium chloride in which attraction force is present among the ions. When this compound has to be converted to gaseous ions, then energy must be applied to this compound. Some amount of energy must be provided to this compound to convert this compound into gaseous ions. The energy that is required to convert 1 mole solid ionic compound into gaseous ions, constituent gaseous ions, then his energy is called lattice energy. The amount of energy which is required to convert 1 mole ionic solid into constituent gaseous ions, that energy is called lattice energy. Actually, the attraction force among ions in the ionic compound is called lattice energy. Now, hydration energy. Suppose sodium ion, 1 mole sodium ions. When this is dissolved in water, then sodium ion will be surrounded by negative ions of negative end of water molecules. Sodium ion will be surrounded by negative ends of water molecules in this way. That is, attraction force will be created between water and sodium ion. In that case, it will produce some amount of energy. This energy is called hydration energy. Again, suppose chloride ion, 1 mole ions here. When it is dissolved in water, then chloride ion will be surrounded by positive end of water in this way. And due to this attraction, it will produce some amount of energy. This energy is known as hydration energy. So, for sodium chloride, hydration energy will be E1 plus E2. Hydration energy for sodium chloride. That is, here we learned lattice energy, the amount of energy, the energy which is present among the positive negative ions, And hydration energy, the energy which is produced due to the hydration of positive and negative ions. So lattice energy and hydration energy. When lattice energy is higher than hydration energy, then the compound will be insoluble in water. But when hydration energy is higher than lattice energy, then compound will be soluble in water. Now let us see the reason behind beryllium hydroxide is insoluble in water and calcium hydroxide is soluble in water. Let us see the matter in detail. Beryllium and calcium, elements of column 2 in the periodic table. Beryllium, magnesium, calcium, strontium, barium, and radium. We know atomic size increases along a column down the group. From top to bottom, atomic size increases. So we can say that beryllium is smaller in size, but calcium is bigger in size. Calcium is bigger in size, but beryllium is smaller in size. Beryllium hydroxide. Beryllium 2 plus charge, hydroxide ion. Here attraction force, electrostatic force of attraction, simply we can call that lattice energy here. And calcium hydroxide, calcium 2 plus charge, hydroxide ion, hydroxide ion. This hydrogen becomes partially positive in charge because oxygen's electronegativity is higher than hydrogen's electronegativity. So this hydrogen becomes partially positive in charge. Similarly, it becomes partially positive in charge. In calcium hydroxide, ionic force present between calcium ion and hydroxide ion. This hydrogen becomes partially positive in charge. This hydrogen becomes partially positive in charge. When beryllium hydroxide is dissolved in water, then there is attraction force between hydrogen of hydroxide ion and water. In this way, attraction force is created between hydrogen of hydroxide ion and water, hydrogen bond, or attraction force is created, which is called hydration energy. So this is hydration energy. Similarly, for calcium hydroxide, lattice energy, here lattice energy, and in this side hydration energy. Now we know that beryllium is smaller in size compared to calcium ion. So here beryllium ion is smaller in size compared to calcium ion. It means in case of beryllium, charge density will be higher compared to calcium ion. The smaller the ionic size, charge density will be higher. The bigger the ionic size, charge density will be comparatively lower. That is, in case of beryllium, charge density, positive charge density is higher, but in case of calcium 2 plus ion, charge density is not higher compared to beryllium ion. So we can say that the more the charge density, the higher the attraction force. The less the charge density, the less the attraction force. In this case, the higher the attraction force, the higher the lattice energy. So, in case of beryllium hydroxide, lattice energy is higher than hydration energy because of this higher attraction force, because of the smaller size of beryllium ion. As lattice energy is higher in case of beryllium hydroxide, in this case hydration energy cannot overcome the lattice energy. That is why this attraction force do not break and beryllium hydroxide doesn't dissolve in water due to the higher lattice energy, and hydration energy cannot exceed the lattice energy. That is why beryllium hydroxide is insoluble in water. Now, in case of calcium hydroxide, here charge density is comparatively lower, so lattice energy will be lower here. That is, hydration energy in this case is higher than lattice energy. Hydration energy is higher, and for this reason, at one stage, the attraction force between calcium ion and hydroxide ion will break, and as hydration energy exceeds the lattice energy, calcium hydroxide dissolves in water. Aqueous. In this case, calcium ion will be surrounded by positive end of negative end of water. In this way, that is, calcium 2 plus ion dissolves in water. Similarly, hydroxide ion partially positive in charge, this is negatively charged. It is surrounded by positive end of water, this is surrounded by negative end of water. That is, hydroxide ion dissolves in water. Hydroxide ion dissolves in water, calcium ion dissolves in water due to the difference in lattice energy and hydration energy. In case of beryllium hydroxide, lattice energy is higher due to the smaller size of beryllium ion. In this case, lattice energy is higher, that is, hydration energy cannot exceed the lattice energy. For this reason, beryllium hydroxide doesn't dissolve in water. But in case of calcium hydroxide, due to the less density of positive charge, lattice energy is lower here. And for this reason, hydration energy can overcome the lattice energy. At one stage, the attraction force between calcium ion and hydroxide ion breaks and it goes to the solution, and in this case hydration energy exceeds the lattice energy due to the lesser charge over calcium ion. So, beryllium hydroxide dissolves in water. Calcium ion is surrounded by negative end of water. Hydroxide ion is surrounded by positive end of water. So, beryllium hydroxide is insoluble in water. Calcium hydroxide is soluble in water. Thanks for watching.